Botswana. More than 500,000 square kilometers and 2.5 million inhabitants, a thinly spread rural population over large spaces. To build and maintain an electrical grid in these circumstances is a great challenge. At the same time, to provide access to clean, sustainable, and cheap energy is vital to guarantee the well-being of rural communities, farms, homes, and businesses. Up until now, the main source of energy for domestic use in the rural world is firewood. We use wood to cook, for heating, and for lighting. Finding that wood is an arduous process, however. People have to move it, find it, and transport it back home, all of which isn't always easy nor safe, a task mostly done by women and children, taking up to 3 hours of their day. The use of wood also comes with risks. The smoke in rural kitchens can be harmful to our health, and wood fire can be dangerous if left unattended. Why not search for energy that is cleaner, safer, and just as sustainable? Let's do an exercise. In Botswana, there's something that thrives: cattle. One of Africa's largest producers of cattle, in our fields graze 2.5 million cows, 300,000 goats, and 200,000 sheep, tended by those who live in precisely the areas where access to energy becomes more complex. But what do cattle have to do with energy? As it turns out, organic matter is an endless source of energy. If we ferment any organic residue under certain circumstances, we obtain gas, and if we manage to store that gas and ensure its supply to our homes, farms, and factories, we give rural communities access to a clean, renewable, safe, and abundant energy source. As it turns out, manure is the organic refuse that is readily available in rural areas. It's abundant, easy to manage and handle, and as long as there's cattle, there will be manure. So we have an underused resource that we can turn into energy. With support from the United Nations Development Programme, the Botswana Institute for Technical Research and Innovation, and the Ministry of Environment have started a pilot project designed to test energy solutions out of this biogas, from use as cooking and heating in small farms to electricity generating in medium and large industries.
Botswana are people with cows, and we are leveraging from the waste generated by the cows and chickens and the pigs so that they can generate gas and use gas for cooking and lighting. People are aware that cow dung can be utilized. It's not a waste. So we can leverage from that and say, since people, it's easy for Botswana to work with cow dung, mix it with soil to harden the houses when they are building and stuff like that. We are using cow dung every day. Let's use it for biogas production now.
I think it is important because once it is here, it is lost. It is not fertile there when it is there. Once you take it again, yes, it is fertile. Yes, it is fertile. But once you take it again and put it in use so that it can generate gas for you, I think that way is better because it gives you something that you will use at home.
I know somebody would say, why not solar? Solar is there, is being tested. But when it comes to biogas, a lot has not been done when it comes to Botswana. I'm not saying it's a new technology. It's not a very new technology, but it has not been tested rigorously when it comes to Botswana conditions.
Our role, in this project is, we manage all types of waste in this country. we are looking at waste as a resource that Botswana can derive some benefits. And this is why, we have vested interest in this biogas production project, because, it's taking one of the waste stream, which otherwise, if you are not managing it properly, will be a nuisance to the environment, and turning it into some products that will benefit Botswana.
So we felt the technology has to be piloted in Botswana. We then decided to select the 4 districts surrounding Gaborone to pilot the technology.
The idea is to develop, test and improve on this biogas reactor technology and make it readily accessible for Botswana's rural communities. For that, they have selected sites in 4 districts in the south of the country: Southeast, Southern, Gauteng and Gwining districts. With digesters being set up and working in these areas, B-Tree's technicians analyze data over the reactor's design, construction and use. Inspired by the proven success of this technology in other countries, B-Tree have adopted designs to the needs of Botswana's rural environment. With available materials in mind to construct and feed these digesters. As well, masons and bricklayers have been selected to undergo training to understand the technology, the materials to use, and the building of the biogas digesters.
UNDP is interested in promoting sustainable development, in looking at climate change issues, in looking at preserving the environment. So through this project, we are looking at waste management, agricultural waste management, and using that waste as a resource.
The aim of the project is to try and assist the government of Botswana in securing energy at household level, at rural places, in towns and cities.
That is to have 1,000 small-scale digesters for household applications. And we would also go a step further. That is to have 3 medium-sized digesters, which are more on the electricity side. But when it comes to medium scale, we are looking at larger production, which will translate into electricity generation.
On a larger scale, B-Tree also researches the use of this technology by medium-scale industries, such as the commercial abattoirs of the Botswana Meat Commission, in order for them to generate biogas from the waste produced from animal slaughter, another source of organic refuse.
The reason that B-Tree is the implementing partner for this project is that B-Tree is a research institution. We have the base design, which is a fixed dome design that is used worldwide. Now, in trying to adapt it for our country, for our conditions, B-Tree, then that's where they come in to see, as we are monitoring and evaluating, is this the best design? So my role is to establish the technical side of the project, which includes designing of the biogas digesters, monitoring them and seeing how efficient they are working. What we wanted to achieve in our country is to develop a design that is not only affordable, but also easy to make. So that's how we decided on the fixed dome digester. It uses materials that are locally available in any part of the country. That's just bricks and sand and water. And also with the training of the masons, we are able to develop capacity for people who can build those digesters.
Training at teng re iretse gone ko Moshopa probably ba tsilehela go le gompie go re tla go tera go kopana le di officera tsa B-Tree ha ba tsena hele re tsena mo classeng re rutiwa the following day be ra site ra go simolla tiro.
What we would basically do, the format that we are following is that we would do our research in our lab. From there, we also build what we call pilot sites, where we can learn the lessons before we move into the 1,000 scale digesters. That's the direction that we've taken. So we are to go around, we are First of all, we are to do a feasibility study to determine which farmer are interested in actually implementing the digester in their farms.
Those who want the digesters should be able to pay for them, right? So that is the financial capability of the farmer. Now, on top of that, we look at other criteria, such as, do you have the substrate to put into the digester? Do you have water to mix with the substrate to put into the digester? Do you have the needs for the gas? Do you need cooking gas? Do you need to offset LPG gas with the biogas? Or do you want to offset your electricity costs? So we look at those simple criteria to say, then that would help you to run your biogas digester efficiently, right? And then, because we do the training of the trainers, we know who is qualified and who can build a digester. We are able to then put these farmers in contact with the masons for them to have their own agreement as to how much it will cost. That is not something that we do, yes, because the project expects the farmers to pay for the digesters themselves.
They told me that they are building a heating digester, and which is going to use the cow dung. So it means thereafter, when they finish, I'll have to operate it to make light for the chickens and the heat. This is why I find it very important to use something else which is less expensive.
The primary use of the gas depends on the scale of production. In our project, we've got 3 scales. We've got small scale, we've got medium scale, and we've got large scale. When you go to small agribusinesses like poultry farms, the gas will then be used for heating and for lighting mainly. For small scale, the primary use is focusing on household use, small micro enterprises, small businesses, which mainly it will be for cooking and for lighting at household level.
I heard about it in the radio. So I was wondering, but how is it possible to, where to get that from? And the brigade teacher came to my home to speak to me about the biogas. And since I wasn't so much aware about it, I wasn't so much knowing what really biogas is, and they are interested in putting their project here at my home. On the 25th of July 2017, they brought all the staff. That's when the building of biogas commenced. And by December, believe me, when it was Christmas holiday, me with my children here, we were all happy because we were now having the biogas at home.
It's a relatively simple process. Biogas is produced when organic material is eaten by bacteria that break it down in the absence of air in a closed oxygen-free environment. From this biological process, methane is produced. Methane, which we can use to power our stoves, generate heat and lighting, and at a larger scale, produce electricity.
You would have cow dung, you would have chicken droppings, you would have waste from the gardens, and leftovers from the kitchens. It depends on the location, what sort of those particular animals what were they grazing from. So that will result, should I say, on the agro-waste that you are then going to feed onto your digester.
The difference between agricultural waste and maybe chemical waste is that agricultural waste decomposes through the action of nature. And through the action of nature, I mean agricultural or agro-waste can decompose through the action of bacteria. It can decompose through the action of other microorganisms like termites.
Right now, I use the cow dung. Dung, normally when you want to keep it healthy and with that gas in it, it has to be wet. Remember, you can't just pick anything dry and then you feed your digester with. It has to be wet.
We put it under the digester and it stays sometimes there 40 to 30 to 40 days. After that, the gas will come out. After putting it for 30 days, then you have to keep on feeding it or on putting the cow dung in the digester almost every day with a 20 liters bucket. Every day you feed the digester so that it can generate gas daily.
Add water. Soft gore ha ke bolesa bo tsena mo teng e be bo le motlhofo to go through the pipe e mo teng ka gore bo ya mo potong e kwa tlase. So if you make it very hard, it won't be easier for the dung to go. It has to go loose so that it can go to stir the pot. You see, it's already wet.
With the risk and time involved in searching fields and forests for firewood, the manure needed to produce biogas can be found in the pens and grazing areas where the kettle is kept, readily accessible to the user, thus saving time for the collection and storage. Cooking, lighting, and heating with gas is safer, as the low pressure of the digester ensures that there is no risk of leakage and uncontrolled combustion. An added benefit is that after the manure has been digested, it becomes high-quality fertilizer for garden or crop use, thus reducing the need to buy or compost by other means.
We have a few demonstration sites that we've put down. And from those demonstration sites, we are able to get data through social interactions with the beneficiaries and through also just observing them as they interact with their digesters, as they use the gas. What we've picked up on is that one thing is not having to go and find firewood. Already we have a problem of deforestation. So you find that women and young girls have to travel long distances to go find firewood. Coming back home late, it is not safe. At times, young girls cannot even do their homework because it is dark. But with the biogas, we found that one, it helps them with warmth, like through winter like this. The light helps them with warmth. It helps them boil water for bathing. So even when it's cold, they don't have to sit outside to make a fire. It helps them also when it's raining, where they don't have to deal with wet firewood. So basically, a lot of small changes in their lives, small changes in the things that they do, is how biogas has improved their lives.
Over and above emission reductions that we can salvage from biogas technology, there's also the aspect of health that comes with carbon monoxide inhaled in households because of use of firewood. It's one of those things that we'll have tried to reduce. There's also the aspect of firewood collection time, especially for women and girl child. With the use of biogas, you are able to reduce on those times or to some extent eliminate them if no firewood collection is to be undertaken by that particular household. There's also the aspect of convenience. When it's raining, you'll be able to cook inside your house because of biogas production.
I can convince him because these times of the year, the wood are no more to be seen. So we have cattle. So you have to use what you have. So if the wood are not there, or if the rain rains, you won't find wood. The wood will be wet. And with this cow dung, you feed it every day, you don't suffer. You use it when it is rain, you just light or you just cook with it. And you don't go around looking for wood. You have cattle, you don't go far.
With the biogas, it's much safer. It's much even better than the previous gas stove, because biogas wouldn't go to an extent of burning the house. It can be much fire when you are lighting. But then, living with the children, whatever you are using, you have to teach them how to use, so that when you are not around, they know how to use safely. I don't want to keep something in the house and to my children I tell them, no, don't touch that, because I don't know when I won't be with them, but they still have to eat. So they also know how to use the stove. They know once you light the stove, you have to adjust the fire to the level where you want to use. So they also know safety of using the biogas, because they also know how to feed the digester itself.
The goal of the government is to ensure that by 2030, 15% of all energy use in Botswana has to be produced by renewable sources. Biogas for medium and large-scale enterprises can help reduce the need for coal, as well as reduce CO2 emissions. At the same time, cutting down pollution of important soil and water resources by using waste that otherwise contributes to pollution. Just as important, with increasing energy needs in the rural sector, the use of firewood inevitably leads to deforestation, which carries dangers to ecosystems like soil erosion, biodiversity loss, and further CO2 emissions.
Areas that could have impacts on the environment do work together to ensure that they share notes and they know what everybody else is doing. Those in agriculture, they know what those in the Ministry of Environment would like to do. So everybody else then, when we are doing planning, has to also be aware of the impacts that climate change can do. So then our programs, our developmental programs, have to be in a manner that we cater for any eventualities that could come about due to climate change. So the biogas program is one of those that that's a project that we are very much interested in, and we believe it is a project that we can be able to replicate elsewhere. And if we are to use the cow dung out of the cow dung to be able to produce gas, then it will be very, very good for the country.
One of the main objectives again of this particular project is actually to cut down on CO2 emissions. The moment you digest your agro-waste, you are actually cutting down on your CO2 emissions.
So we anticipate and believe that with biogas technology, we'll be able to offset several environmental management issues that industries are grappling with. And I want to emphasize that this is a resource. The organic waste that they generate is a resource that they can use to offset some of the energy costs that they are having to run their industries.
I know the time to come back to prepare tea for my mother, because I don't have to fetch firewood. I don't have to start thinking, where am I going to start? I know when I have got gas, then life is easier.